Okay, and as for like this point is like you know, sometimes the name may be a little. Excuse me, what happened? 喂？
你好，我这里是中立的波波凯陶汽车必须位。
我知道，我在上课，对对对，不好意思。
大概11点会好。
OK， 好，谢谢，好，拜拜。
要麻烦您带印章过来盖和解除哦。
OK， 好，拜。
好，谢谢，拜拜。
Yeah, sorry about that. Okay. So sometimes, as I said, like some names are not exactly what it meant, okay, or like it may be, the name may seem a little bit misleading, okay, because the author, I mean, intentionally give an example, okay, because I mean, they are, I believe they are Mexican, okay, or like Spanish people, okay. I mean, there's a dish called sopa seca, okay. If you directly translate that name, it's called dry soup. Dry soup. If you consider this name, that's interesting, right? Because, you know, the soup must be liquid, right? I mean, when a soup is dry, how can you drink it, right? So you know, but you know, this name, okay, maybe sounds like a misnomer. Okay, misnomer just like a incorrect name, okay, or oxymoron. Oxymoron just means it's contradiction, okay. But anyway, okay, I mean, if you understand how this dish is prepared, I mean, then we can understand how, you know, why it is called this dry soup. Okay, same thing applied for like logistic regression, because you see this term logistic regression. I mean, logistic. Okay, this part means like we apply logistic function in for the inverse link function. So we know that, but regression normally is used to for a numerical result, because we regress to a number. Okay, in mathematics, this is like normally how we call it. Okay, I mean when you have a regression, the result is normally it's going to be a number, but obviously, you know, in this logistic regression, the result is not a number; it's categorical, right? It's a binary classification, right? So, but once you understand, okay, the concept, because we use logistic, okay, on this linear combination, okay, that linear combination can be considered as a regression. So we use this logistic function on the regression, the result of the linear combination, to obtain the probability. Okay, so you know, although we call it regression, okay, it's generally framed as a method to solve classification problems. It's really not to use to solve like a numerical regression problem. Okay. Oh, sorry. So logistic function. What is logistic function? Logistic function looks like this. Okay. You know. So it's the denominator is 1 plus e to the power of negative z. Okay, where z is the argument. Okay, and the numerator is a 1. Okay, and this value, okay, obviously when z is 0, okay, the result is going to be 0.5. But when z is very large, the result is going to be, you know, when z is large, I mean, this term becomes smaller and smaller, right? So the whole thing will get closer and closer to 1. Okay, and when z is negative, then this e to the power of negative z is going to be, larger and larger, and because the denominator is going to be very, very large, so the resulting logistic value is going to be, close to 0. So it's in the range of 0 and 1. Okay, and with a mean, okay, at 0.5. If we draw it, okay, it looks like something like this. Okay, when z is 0, it's 0.5. When z is negative, okay, it's getting closer to 0. When z is positive, it's getting closer to 1. Okay, and obviously, the shape of this function looks like an S, right? Okay, so another name that calls the logistic function is called sigmoid. Okay, sigmoid, also known as sigmoid function. That's because, okay, the S shape looking of this function. Okay, so we call it sigmoid. Okay, if you are into deep learning, we normally don't call this function as like a logistic. We normally call this function sigmoid, which actually is one of the earliest used activation functions in deep learning. Okay, but yeah, let's not dive into that direction. Okay, first I just want you to understand this is logistic function. Okay. So we are running out of time. Let's take a 10 minutes break. When we come back, we'll continue our discussion. Okay.